Good morning. So today we're going to talk about the difference between linear and quadratic equations and finding the line of best fit. We've already talked about the linear. Remember we did our linear regression on our calculator a while back. So what we're going to do is that we're going to plot the points and decide if it's either linear or a quadratic. If it's linear, then the equation is going to be in the form y equals mx plus b. If it's a quadratic, it's going to cross on the x-axis. It's going to have two x-intercepts here, not all the time. And then it'll have the form y equals ax squared plus bx plus c. So that's what that will look like. Okay, so how are we going to do this? We're going to have some data values. So when we get those data values, we're going to plot those, no matter what. Okay, after you plot those on the graph, you're going to look at it and determine if it's going to look like a linear, so if it's a straight line, or if it's a U. And the parabola is is a U. Okay, so after you determine if it's a straight line or a parabola, okay, then you're going to use your calculator, okay, and remember you're going to go to Stat on your calculator and go to Edit. Oops, if I can spell edit there. Okay. And in that stat and edit, you will input your data values. So input x values in the first column and input y values in the second column. Okay? All right, so after you determine if it's a straight line or a parabola from your little plots, okay, this is where then you'll go. Okay, so after you input those values, okay, then you'll go back to Stat, okay, and go over to Calc on the calculator. So go over to the Calc. Okay, and if it was a straight line, okay, so this is when you see if your data values, if they were a straight line or a parabola. So if it was a straight line, then okay, then you're going to go down to the linear regression. On my calculator, it's number 4, but okay, if it was a U-shaped, then you will go down to quadratic regression. Okay, so the quadratic regression on my calculator is number 5. Everybody's calculator is a little bit different. That linear regression was a number 4 on after you go to the calc part of it. Okay, everybody's calculator is a little bit different. That's why I don't want to say what number it is. Okay, so let's look here. So So, if I've got this going on here, okay, so -2, -7, so we're going to plot a point at -2, -7. Sorry, thing. Okay, then we're going to plot a point at 0, -3, 1 at 1, -1, 1 at 3, +3, and then 5, 7. Okay, so what does this look like? This looks like a straight line, right? So this is going to be a linear model. Oops. Okay, it's a linear model. You could just try to look at the slope. It has a y-intercept of a -3, right? And you could find the slope of, remember it's rise over run, so it'd be 1, 2, 3, 4 over 1, 2. So your slope would be 4 over 2, which is a 2. So the linear regression here would be y equals 2x minus a 3, because that -3 is your y-intercept, okay? But I want to use our calculator so that you could see this as well, okay? Okay, so now let's try to go to our calculator. So get your calculator, okay, and go click on the Stat button, okay, then click on Edit, so that should just be right there. Okay, and when you click on Edit, so then you'll have your table values that'll come up. Top of my calculator says line 1 at the top, like this, so this would be line 1, and then this would be, mine says line 3 for some reason at the top. Okay, you'll input each one of those values, so -2, 0, 1, 3, 5 in that first column. Then go over and type in your -7, -3, -1, 3, and 7. Okay? Now, since we see that it's linear, so then we're going to click back on Stat. Okay, go over to Calc. So over to Calc. Okay, and it's linear, so I'm going to go down to the linear regression. Okay, enter, calculate. Okay, so you see that it's got the form. It's got, on your calculator, it says y equals ax plus b, and it says a is equal to 2, and b is equal to a -3. And so that would give me my formula here, because it represents the coefficients in front of those. Okay? All right, let's look at another one. Here we've got, let's plot these points. So we've got 1, -5, 1, -5, 2, -2, 3, -1, 4, -2, 5, -5. Okay, so what does this one look like? This one looks like a parabola, right? Okay, so this one, it would be a quadratic. Okay, so my equation here, so since it's a quadratic, there's no y-intercepts here, so I'm not going to be able to find my y-intercepts. I'm sorry, there's no x-intercepts, so I'm not going to be able to find my x-intercepts and multiply. So we're going to go to our calculator, okay, and go to your Stat. So go to Stat, and click on Edit. Okay, and put these values in line 1, put these values in line 3. Mine says line 3, I'm sorry. Yours may say line 2. Okay, so I'm going to put 1, 2, 3, 4, and 5 in there. And then I'm going to go over to my line 3 and put in -5, -2, -1, -2, and -5. Okay, and since I see that's quadratic, then I'm going to click back on Stat, go over to Calc, okay, and go down to Quadratic. It should look something like this, Quadratic Regression. Okay, so make sure your X values are in list 1, your Y values are in list 3, and then go to Calculate. Okay, so on your screen you should see this form, ax squared plus bx plus c. Okay, and it says A is -1, B is 6, and C is a -10. So that means that my quadratic equation is going to be a -1x squared plus a 6x minus a 10. It's pretty cool. Okay. Alrighty. So that is how you put in your calculator looking at linear and quadratic regression. So make sure that the first thing you do is plot your points and determine what type of value, what it's going to be looking like, what the plots are going to be looking like. All right. Okay. Y'all have a good day, and I want y'all to finish up those worksheets.